Hello everyone, welcome to RoshChem summary videos. In this video, I'm summarizing the lesson, the periodic table. Okay, we will look at the trends in properties of elements in the periodic table. So the first one is the co-charge. So what is the co-charge? It is the attractive force of the nucleus of an atom on the valence electron. That's the definition of the co-charge. In other words, what is co-charge? If you take any atom, the valence electrons are not experiencing the full charge of the nucleus because it is covered by inner shells. So therefore, we say the valence electrons are experiencing a co-charge. So there is a way to calculate the co-charge. This is the formula to find the co-charge. So it's atomic number minus all the inner shell electrons. So for example, if you take a chlorine atom, so atomic number is 17, which in other words, it got 17 protons and 17 electrons. So minus all the inner shell electrons. So how do we find the inner shell electrons? So we can write the configuration of chlorine. So it's 2, 17 is what? 2, 8, 7. So inner shells are then these two. So inner shell electrons are then 10. So atomic number is 17 minus the inner shell electrons 10 gives you a co-charge of 7. So we say plus 7 because co-charge is the attractive force of the nucleus, which is positive. So co-charge is for chlorine is plus 7. So like that, we can calculate the co-charge for any element. So these are the calculated values for different elements from different elements or from different groups. You can see group 1, any element from group 1 will have a co-charge of plus 1. So group 2 will show plus 2, group 13 plus 3, so then plus 4 plus 5. So like that, you can see when you grow from group 1 to group 18, the co-charge is increasing. So what is the trend then? So across a period, so when you go from left to right across a period, the co-charge is increasing. So what will happen to the co-charge when you go down the same group? You can see if it is group 1, co-charge for any element in group 1 is plus 1. Group 16, any element is plus 6, which means the co-charge remain constant down a group. So the trend is down a group remain constant. Across a period, the co-charge increases. Okay, we will look at the next property now. The next one is electronegativity. So what is electronegativity? The electronegativity is a measure of the tendency of an atom to attract the bonding pair of electrons. So when atoms make bond, so how easily the atoms attract the electrons. So there are some atoms which can attract electrons more than the other ones. So then I say those atoms are more electronegative. Right? For example, if you take HCl molecule, so it's made from hydrogen and chlorine, the chlorine can attract the bonding electrons more easily than hydrogen. Therefore, I say chlorine is more electronegative than hydrogen. So we'll see what is the trend for electronegativity. So when you go down a group, the electronegativity is decreasing. The reason is when you go down a group, so if you take the same group, like we'll take group 1, in group 1, you have sodium, potassium. We'll just take these two elements. If you write the configuration, sodium is 11, so which means 281. Potassium is 19, so that is 2881. So what you can see then when you go down the group this way, the number of shells are increasing. So therefore, number of shells are increasing. Therefore, the atom cannot easily attract the bonding pair of electrons because now the bond electrons are far away from the nucleus due to the higher number of shells. Therefore, I can say when you go down a group, because the number of shells are increasing, the electronegativity will decrease. The atom, the nucleus cannot easily attract the bonding pair of electrons. Then what will happen to the electronegativity when you go across a period from left to right this way? So what happens is we know that now we just discuss about the co-charge. So I just said co-charge is increasing when you go across. Therefore, the electronegativity will also increase. Why? The co-charge higher means the nucleus attracting power is higher. So therefore, the bonding pair of electrons will be attracted towards the nucleus. Therefore, the electronegativity will be higher. Right? When you go across the period, the electronegativity will increase. Okay, we will now look at the next property, the third one. So which is the atomic radius or the size of the atom. So what happens? So we know when you go down a group, atomic radius is increasing. The reason is when you go down the same group, the number of shells are increasing, therefore the atom become larger. So what happens when you go across a period? So when you go across a period, the number of shells doesn't change, they remain constant. So if you take, for example, if you take magnesium and aluminium, they are from the same period. So magnesium is 12, so which means it's 282. Aluminium is 13, so that's 283. So you can see they both have 3 shells, but still the atomic radius decrease. The reason here is when you go across that way from left to right, the co-charge is increasing. So co-charge increasing means the nucleus can pull the electrons towards itself, so that will shrink the atom. So therefore the atomic radius or the size of the atom will decrease. So therefore the trend is going down a group, atomic radius increasing. That's due to the increase in number of shells, and across a period the atomic radius is decreasing. That's due to the increase in co-charge. Okay, so the next property is first ionization energy. So what is this first ionization energy? It is the amount of energy needed to remove the valence electron from an atom. So it says, if you look at the definition here, the energy required to remove the most loosely held electron, that is the valence electron, from a gaseous atom to produce a gaseous ion with a charge of +1. Because when you remove electrons from an atom, you get positive charge ion, or you say cation. So this is how you represent the ionization. So you have a metal like M. So M is your element in gaseous state. So after removing the electron, now it becomes M+, which is in gaseous state. The electron you remove, you write on the right hand side. That's how you represent the ionization of an atom. So what is the trend now? So when you go down a group, we say the ionization energy decreasing. So reason here is when you go down a group, the number of shells are increasing. So if the number of shells are increasing, the last electron, the valence electron, is far away from the nucleus. So therefore it's less strongly attracted to the nucleus. If it is far away, it's less attracted to the nucleus. So you can remove that electron very easily with less energy. So that's why that electron require less energy. So therefore the ionization energy is lower, right? So when you go down a group, therefore the ionization energy is decreasing. So across a period, what happens across a period? The ionization energy is increasing. What is the reason for that? When you go across, we know the co-charge is increasing, which means the nucleus is now pulling the electrons, or the electrons are more attracted when you go across. So the right hand side elements, electrons are more attracted to the nucleus, therefore difficult to remove. If it is difficult to remove, we should give more energy to remove them. That's why the ionization energy is increasing. So remember the trend then, when you go down a group, ionization energy decrease. When you go across, the ionization energy is increasing. Okay, so that's the end of this video. So please do questions from RoshChem's 1 and 2 study guide. You can find them and the summary notes on pages 17 to 30. So thanks for watching my video. If you need further information, please visit our website www.roshchem.com. Thank you. I will see you in another video.